Good morning, ladies and gentlemen. My name is Miguel Ramos. I'm a technical officer in the ARPAS program, and I'll be honored to be your master of ceremonies for this morning's session. Before we start, let me remind you that this is a stream A, dealing with registration. So if you want to go for communication, is the next door. If you want to go for geofencing, is down in 3. Anyway. Yesterday, we had a very interesting and provocative presentations and discussions. One of the most predominant aspects of yesterday's presentations were the aspects that UTM in the registration, identification, and tracking, which is a need. UTM relies on data about the aircraft operating within the system. The data is obtained through a registration system that permits real-time identification and tracking of aircraft. This particular session will showcase potential registration systems that may have a global applicability. And before I introduce our moderator for this morning, please keep in mind that for your questions, you will still have the email address that we have yesterday, plenary@icao.int. So as I said before, to lead us into the discussions of this session, we have Dr. Hiroko Nakamura, Deputy Director General at Japan Unmanned System Traffic and Radio Management Consortium, JUTM. Dr. Hiroko Nakamura is a Project Associate Professor at the University of Tokyo and also the Deputy Director General at the Japan Unmanned System Traffic and Radio Management Consortium, namely JUTM. JUTM is a consortium that includes members and observers from more than 140 companies, institutes, and agencies. She will lead an UTM demonstration this October at the consortium, where demonstration will test the UTM concepts and connecting flights for delivery services and the disaster management process by local governments using UTM. Seems to be going to be very interesting. We will really love to participate. Her work is highly respected in Japan, where UAS safety has been under the Civil Aeronautics Act since 2015. More than 12,000 applications are submitted annually to the Civil Aviation Bureau as permission requests for specific operations such as BLOS, flights over populated areas, or flights closer than 30 meters to people and buildings. The government has also made an investment of more than $7 million constructing a robot test area in Minamisoma, city of Fukushima Prefecture. May I invite our moderator, Dr. Nakamura, to the podium, please? Welcome.
Thank you, Makio, for kind introducing me. Good morning, everyone. It is my pleasure and honor to be the moderator here. Actually, I couldn't sleep yesterday. It's not due to the jet lag, but I'm just excited about this session. And ladies and gentlemen, again, thank you very much for coming to this session. That must be difficult for you to choose this session among 3 interesting parallel sessions. But I think you choose the right one. Because registration, identification, and tracking is really the fundamental for drone management. Anyway, you choose this airspace, so I assume that you are registered to fly in this airspace during this morning. So please be careful. Your position is tracked by me. And once you go out of the hall, you will be identified, and you cannot get coffee there. So please enjoy by the end. But don't worry, we have great speakers today. So it's so exciting. You can't leave this room. I can't wait for their presentation. So I explain logistic things. Every presenter have 15 minutes to present. And after for presentator, we have a Q&A session, and that is based on your question. So as Makida said, please send your questions to the email address written here. So I'd like to present the first speaker, Mr. Walter Stockwell. Director of Technical Standard at DJI. Dr. Stockwell earned his PhD in particle astrophysics at UC Berkeley. Since leaving academia, he has worked a variety of roles in companies exploring the revolution in cheap, low-power, capable sensors. At Crossbow Technology, he helped create the first MEMS-based FAA-certified AIROS system. Dr. Stockwell has worked in a variety of industries that require high reliability and safety: aviation, oil and gas, and automotive. Risk management is key to successful deployment in all of these industries. He is the Director of Technical Standards at DJI, working to bring partnership to government and industry in the growing UAS field. He represented DJI on the FAA Micro ARC and ID ARC and actively participates in standards, work with ASTM, ISO, EuroCAE, and RTCA. So please, floor is yours.
Thank you. So, okay. Thank you for the introduction, and thank you everyone for coming. So I want to talk today about remote ID, and sort of with this theme that we should use the radio you have. So let's start. I'm still learning how to use the clicker. Okay, so what's the problem set we're looking at here? If you think about automobiles, if you see a car drive by and it's speeding, you can look at a license plate on it and report that to the police, and they can use the license plate to track down who that was. When you look at a drone in the sky, though, you just see this sort of small object flying around, if you can see it at all, and there's no room for a plate that could be visible enough for someone to physically read it. So that's the kind of thing I think we want to recreate for drones, is a way to identify a license plate. Then that license plate could be used to track down who's responsible for that drone flying around. But once you have that, why not go a little bit farther? Why not try to say, like, well, have the drone report where it's located, where it's going, its altitude, its vector, what type of drone it is, perhaps, because that could be interesting. It could help you understand payload capacity or what kind of threat it might pose. And maybe even what it's doing. Is it someone flying recreationally? Is it a commercial operation? Is it one of these future drone deliveries that people are hoping to do? So this is all information that would be very useful to people regulating airspace. So we think we have a solution for this. And it's really, our suggestion is let's leverage the existing radios that are on the drones anyway. So every drone will have a command and control link. Why can't we embed this information in that C2 link? And one of the things we think is interesting about this is that the transmission range then of this kind of information scales with the size and capability of the drone. So if you have sort of a toy drone or a recreational drone, someone flying in a park, maybe they're using Wi-Fi, it only has a range of 100 meters. Does someone 5 kilometers away really need to know what that drone is doing in the park? We would say probably not. However, if you have a drone that's flying kilometers and it's being controlled by someone, there's a link there, and so that link is being broadcast, and someone in a range of kilometers can get that information about the ID. So this is, I think, also an interesting topic because RF broadcast range on the C2 link is sort of a marketing point of sale, right? So you need to have a strong C2 link to control your drone. If you have a bad C2 link, people won't buy your drone. So the fact that you have a strong C2 link also makes it a good candidate for using for ID. So just as a sort of overview, I guess I don't have a pointer to point at things, but you can kind of see conceptually we have some of these drones flying. There's a person on the ground controlling it, so that's the little yellow lightning bolts, the C2 link between the drone and the person on the ground. But then you can have a receiver that's receiving this ID packet off of this C2 link, and it can hear anything within broadcast range. And that receiver then can connect to some sort of display so that whoever is monitoring these drones or interested in this, whatever is going on in the airspace can see that. So that's the basic concept of using that existing C2 link, adding this information for ID and tracking, and just broadcasting it so that anyone with a capable receiver can get that ID and tracking if they're in range. So here's, I think, some of the advantages of this method is when you do this, it's really built into the function of the drone itself. So it's not something the user really has a choice about turning on and off. It's not something they have to configure. It's just when you turn the drone on, if your C2 link is working, this packet's being transmitted along with it, so it's automatic with every time you turn on the drone. It really is pretty much zero burden to the person using it. So there's there are no issues with the person perhaps complaining. Now they're being tracked. They're not being forced to pay for that, sort of, or having other burdens going along with that. There's zero other network costs, sunk costs, or maintenance costs for this. And basically, it will work anywhere. So anywhere that the C2 link works, someone can receive the C2 link to control it. Then someone else can receive that broadcast to ID and track it. And it should be easy to retrofit on most drones. It could be a software update. They already have a C2 link. You're not changing hardware. All you're doing is changing software to add extra packets into that C2 link that can be read by a receiver. And it's really, I would say, an international solution because it's tied to whatever C2 link is local in that jurisdiction. So, of course, there are issues with what is an ISM band or what are legal bands to use in various countries, and what we use in the United States may not be the same thing you use in Japan. But whoever is using that drone in Japan, they will be using a legal C2 link frequency, and so Japan can have receivers that receive information on that link. So really hopefully one of the points is that you, as a manufacturer, you build this technology in, and then it's just out in the world for use, so that the person who's flying the drone is in compliance with whatever local rules are there. So we think there are some other important considerations. So we are a manufacturer. We have customers. We get feedback from customers. We think a significant number of our customers are concerned about ID and tracking. They're concerned about, if I'm flying around, is someone going to know, it's me and come to my house and assault me because they think I'm spying on them? We've had reports in the USA of people shooting down drones. So there's sometimes a hostile environment, and so people are concerned about protecting their private information. So we call that the PII, the private identifying information, personal identifying information. And so there are sort of individual privacy concerns, and I think there are also very important commercial concerns. So if, for example, I have a roof inspection business or some sort of commercial building facade inspection. I may work hard to get a certain contract with a certain building, and I start flying there. I don't necessarily want my competitors to know who I have contracts with, because then they'll go talk to them and try to steal my contracts. So there's an aspect of regulation, but there's also an aspect, I think, of complying with regulation and encouraging people that the benefit of ID and tracking outweighs what they might see as negatives of having their sensitive commercial information or personal information somehow available publicly. And so by having this ID and tracking limited to the broadcast range and limited to the time that the person's flying, so someone has to be there with a receiver to get it, that's sort of limiting the impact of the data collection. So that in theory, if it's sort of like if you're speeding in a car, if someone's there to see you speed, they can catch you and pull you over. If you're speeding in the middle of the country and no one catches you, then I guess that's not a bad thing. You haven't hurt anyone. Why do you need to be tracked for that? There's another important consideration, I think, that sort of balances that, is that really this is sort of a tamper-proof solution. Because this is part of the C2 link, someone can't just clip a wire to turn off the ID and tracking. If they clip the wire, they won't be able to control the drone. So this is balancing those concerns. We also include, or you could include a serial number so that it's really verifiable and a unique ID. And it helps address a situation where people may not have access to the internet for various reasons. A lot of people don't fly connected to the internet, or they might be in situations or areas where the internet is not available, but you could still ID them using this method. Okay, 15 minutes goes very quickly. I'm going to hit just some high points. So this kind of echoes again what I was saying about really this helps in areas where there's no internet connection. It's this direct broadcast. Anyone can get it if they're in range and have the receiver. And what I want to say about today really is that this is a solution we have created and deployed, actually. So we have this built into our C2 link for our wireless protocols. So any DJI drone now on the market can be detected using this method. And we're working on an open standard wireless or Wi-Fi protocol with the idea that eventually, as an industry, we need to come up with some standard way of doing this, not just DJI. And so as a first step, we're making a Wi-Fi protocol that anyone could implement, again, through a software update by adding packets to the Wi-Fi. And so this is really ready now. On the drone side, we have this packet implemented in our devices. On the ground side, we have receivers developed and built and actually deployed in 2 major airports in China. So they're collecting data as we speak on drones that are flying near them within broadcast range, which would be the ones that would be of interest to the airport. If it's 20 miles outside the airport, they're not interested. They're only interested when it actually comes and starts to intrude on the airspace right around the airport. And again, the one thing we would say is that this will benefit from really a standardization process and gaining wider industry support so that there's a clear path forward for all of industry, not just DJI. But we have this actually installed, as I said. So here are some pictures of, we have sort of a waterproof, deployable outside box. You mount it on a mast. You put receiver or antennas up on top of the receiver. We've made portable models. So that's the picture on the lower side with a little stand and a display. And the kind of information that our current system can give you are the drone position and altitude and speed. If the control station has a GPS, whether it's from the phone or something built in the control station, we can actually report that through the C2 link. So you can have access not only to where the drone is, but who's controlling it, where they are. We can report the serial number of the drone itself. So that's a unique ID built into the hardware that the user can't change or spoof that. We've added, for now, this idea of sort of user-defined fields. So depending on where you are, you might have, in the United States, you might have a Part 107 remote pilot certificate, so you could insert that number in this. You could have your FAA registration number, you could insert that in there. And going forward in the future, different jurisdictions could figure out different ways of what kind of numbers they want there. And also maybe some measure of intent, like whether you're commercial or recreational, delivery drone, inspection. And you could easily extend it to add other info that might be interesting, like are you in a return to home state? What's the battery life left on this? What kind of range might you fly? So those are things that could be interesting as well. So I think I'm going to hit my time exactly. In conclusion, ID and tracking exists. We have a solution. It's the radios that are already there, so let's use them. And this is a very sort of quick, easy, inexpensive way to do ID and tracking today. Thank you.
Thank you very much, Dr. Stockwell. The presentation was very interesting. As a manufacturer's viewpoint, you proposed the methodology how to identify drone remotely with existing technology, and you express some concerns from user side. That's an important input, and also presentation about the deployment into international airport. That's really informative. Thank you very much. So I'd like to present the next speakers, Mr. Jared Ablon, Chief Information Security Officer at AirMap. Mr. Jared Ablon is AirMap's Chief Information Security Officer. Ablon has more than 12 years of experience in both offensive and defensive security. Most recently, he worked at MITRE Corporation, where he led efforts to ensure security of next-generation GPS navigation systems and other communication technologies for multiple U.S. Air Force programs. Mr. Ablon founded PassRock, which developed a commercial fraud prevention solution for business to mitigate the risk of stolen user accounts. He also had led large teams of security experts and tackled nearly intractable problems by developing cutting-edge cryptanalysis, network exploration, and vulnerability analysis security technologies, U.S. Department of Defense. So, floor is yours.
Thank you. It's a pleasure to be here today in Montreal with all of you. So today, industry stakeholders do not have a way to remotely identify drones. And this is a fundamental technology that needs to be developed to have high volume operations, especially in places over people or in controlled airspace. So it's a pleasure to talk on this topic today. AirMap has been involved on the FAA Remote ID ARC. We've been involved with the Global UTM Association and the Consumer Technology Association trying to develop remote ID technology. And so I'm here to talk about some of the things we've learned. So we believe that drones need to have their own unique identity separate from the operator. This is very similar to aircraft and pilots or a car and a driver. Car has a license plate, a plane has a tail number. Each of these identities identifies the vehicle, and it can be tied back to the owner, but it is not one and the same. For example, drones are going to be flown by companies. Companies are going to own them. They're going to have various operators. They're going to own multitudes of drones. So we believe it's important to have a specific number for the drone. And like Walter said, the drone can't have something written on it. A license plate, 400 feet in the air, you can't really see that number. So it's important that we have a digital identification and a way to see that number while on the ground. So some of our guiding principles in thinking about this problem. So first, it needs to be easy for the drone manufacturers and developers to implement. We want to keep size, weight, and power down, because obviously all of those things affect the performance of unmanned aircraft. So we try to think of a solution that's something that can already be implemented, what's already on the drone, Wi-Fi, LTE potentially, Bluetooth, what technologies can we leverage that are on the drone today. Next, we think it should be independent of proprietary technologies. It needs to really be open so it can be widely adopted around the world. And then it should be trusted and secure. So if someone says, if a drone says their ID is one thing, you should believe that, and it should be trusted. It should be low cost, right? We don't want to add additional burden to either manufacturers or ultimately the end consumers. And it should be easily scalable, because we are going to live in a world with millions and millions of drones. So what does it look like from a high-level remote identification? And so first, it's about verifying an identification, then broadcasting that identification out, and then having access and validating that identification. So when we talk about verifying an identification, we're talking about an operator saying, I own this drone, and verifying that they are in fact in possession of that drone. So we believe that the digital identity that I spoke of should be in the form of a certificate, a digital certificate, often called a PKI, or Public Key Infrastructure Certificate, which is based on public key cryptography. So the certificate and validating the identification of the operator or the owner, email address, phone number, name, address, those types of things, can be in conjunction with registration or separate from registration. This is merely an identification, same as a driver's license or a license plate. It's not necessarily the system that has all of the personal information and the registration system. So this is agnostic to what's done in terms of registration. So what are digital certificates? So the most commonly known digital certificates are X509 certificates, which is commonly referred to as TLS or SSL certificates. So when you go to a website and you type HTTPS and you get the lock or the green bar in the browser, your browser knows that you actually are in fact talking to the site that it thinks it is. And it verifies that with authentication based on this cryptographic certificate. Additionally, these certificates are being used more and more with IoT devices. So IoT is Internet of Things. It's internet on your refrigerator or in your toaster, or all the things that are now getting internet. A lot of them are using certificates in order to authenticate. So there are more than 1,400 certificate authorities already in place today. So this is already a scalable solution. Millions and millions and millions of websites are using these certificates. There are over 1,000 places to get these certificates. And something I'll mention is whether the ID works the same with unmanned aircraft, where you first get the aircraft and then register it and get an ID for that. It could also be done at the manufacturer. The manufacturer can put in a certificate in a hardware security module and put it on instead of actually registering. So this identification is agnostic to actually implementation of it. So next, so after you've you verified the owner of the certificate, you've gotten an ID back with a certificate, you would then broadcast the ID. So what are the different broadcast methods? There's a variety of them. People have talked about using ADS-B, direct RF, network cellular, satellite. Using a certificate as an ID is agnostic to the broadcast method. However, there are some considerations when determining what you would like to broadcast. What's the medium? Does it matter if someone's flying in a place and they lose cellular connectivity? Is that a problem? If it is, then you may need a direct radio frequency broadcast. What if you don't want someone out of the direct region? What broadcast method would you use? Obviously, even if you're using something that's networked, you could still put on access controls and authentication, so only people in the local area can actually view that. So what should be broadcast? At a minimum, we think the identifying number of the drone, the location of the drone, and a timestamp, that should be broadcast at regular intervals so that people can identify that drone. The identifying number also can be abstracted. It can be anonymized, just like a license plate, and only certain authorities can go and actually see who the owner of that is. Also, it should be digitally signed. So what does that mean, digitally signed? So once you have a certificate-based system, you can digitally sign the information, which means it came from a known sender, so that you have authentication there. That sender cannot deny having sent it, so you have non-repudiation. And then lastly, you have the integrity of the message. So no one can modify that message without you knowing. So we believe that's extremely important in having a trusted system. So lastly, I'm going to talk about access and validating the ID. So for access, we believe having access on a mobile application is ideal. Mobile phones, smartphones are pretty ubiquitous. Most people have mobile phones. It makes it really easy and cheap to disseminate the information. It's already scaled out. Most people have them. So be able to access the ID on a phone. And again, access controls and authentication can be put in place if it's determined that you only want people in a certain region to see it, or you only want the authorities to see who that information is. And then next comes validating the ID. So enable to ensure, like I said earlier, that you know who the person says they are, you would check the digital signature once you see the message, the broadcast on a mobile device, you check the digital signature. And that is important to help prevent spoofing. And so what spoofing is, if someone fakes their identification and they say they're someone they are not. That obviously is something we would like to avoid, because remote identification is about creating accountability so that we can have a safe environment for high volume flights. To validate, you would check the digital signature to make sure they are who they say they are. Now, the reason why this is important in the digital realm is because if you think about it in the physical world, if someone was going to spoof a license plate, they have to physically make a license plate. They have to go out to a vehicle. They have to change a license plate. It is very costly in terms of time and money. It's not scalable. If you think about someone doing that 1 million times, it's almost impossible for a person to do. They really have to have something more massive. However, on the digital side, you could have someone in their basement spending almost no time or money, and they can scale an attack where they're saying drones are all over the place. And so that's why it's important to have a trusted system in the digital world, because attacks are scalable and they can be done by a single person and have massive effect. So I will leave you with, I believe that remote identification is one of the big steps to help open up the airspace. It's an extremely exciting time that we're in here. That once we have some of these standards in place, that we will have high volume flights around the world, and that's extremely exciting. I'm looking forward to any questions you have that I'll answer during the panel. Thank you.
Thank you very much, Mr. Ablon. You presented about how to manage the how to manage the identity of drones during the remote identification process. Especially, you highlighted trusted system is important, and digital certificate which scalable and scalable digital certification method that you proposed, and that was very interesting, and very thank you very much for your presentation. So next speaker is Mr. Ken Stewart, Principal Product Manager from AIROS. Ken Stewart is at AIROS at GE Venture Company. Mr. Stewart has been a wireless telecom business innovator, entrepreneur for more than 20 years, building business in the US, Europe, and Asia at senior management level, covering a broad range of products and technologies. So, Mr. Stewart, please, the floor is yours.
Good morning, and thank you for having us here this morning. Thank you. So, many of you may not be familiar with AIROS, but I think you're probably familiar with our parent company and our main investors, GE. Hopefully our name will be as common as theirs in this space at some point in the future. So today, wanted to, see if I can't get this going. Oh, thank you. Okay. To talk about our proposal for authoritative registry for positive ID and tracking. So today is, as we've talked about already in the two previous presentations, it's nearly impossible to identify a UAV flying around today, and even more challenging to identify the owner-operator of this device. I can tell you I've just spent 4 months on the FAA ARC for positive ID and tracking, and I was fortunate enough to sit with law enforcement. Quite interesting, the challenges that they see day in, day out, and quite frankly, that really reinforced my belief in that all UAVs, besides toys, should essentially have some sort of ID assigned to them. So the industry really needs reliable, globally harmonized standard for identification so that we can scale to meet the growing use of drones. So what is an authoritative registry? It's something we see in many other industries, actually. It's a source of truth. In telecommunications, we have what's called here in North America, both in Canada, United States, Mexico, NAMPA, which manages all of our +1 numbers. How do your phone calls get routed? How do you know how to route when you travel with your phone to this country? How do we deliver your calls? It's a source of truth for who and where this number belongs. Much like in the internet domain, where you have TLDs and other registered domains, where how do you route to that website? When you go in and type your favorite website, how are you going to be routed to that? So registries are fundamental in terms of how do we scale large global businesses, phones, telecommunications, internet. And quite frankly, the authoritative registry really forms the foundation for establishing a consistent standard for UTM and positive ID moving forward. And if you think about in terms of portability, you'll want this. If you have an ID with a drone or a UAV, you'll want it to stay with it for its lifetime or life cycle. In this space, you can port between service providers, just like people may port between UTM providers, and the same with domain providers for URLs and domains. So as a source of truth, there are really 3 kind of buckets that UAVs fall into, and we call the 3 C's. We have our conforming, the people that are doing the things that they're supposed to be doing. We have careless, the people that may think they're doing what they're supposed to be doing, but may not necessarily be doing what they're doing. And criminal, which is obviously a small group, but still, how do you identify what these 3 particular buckets are doing, and then act accordingly? If they're conforming, there's no need to interoperate with them. If they're careless, that's another opportunity for us to go and educate them on what they should be doing. The fact that they're registering makes it easier to find the operator to be able to have those conversations with. And then lastly, the criminal types, then law enforcement can act as necessary as quickly as possible. So what are the requirements for an authoritative registry? It needs to be reliable, needs to be scalable, needs to be globally harmonized. We've seen this in other industries where it's been very successful. It needs a scale to meet the need of the exponential growth of UAVs. If we really want to see this service and industry take off, there needs to be a standard. Much we talked about on the OEM side, they already have a lot of the capabilities that we're going to talk about. To establish a standard, consistent, tamper-resistant method. We talked about SSLs. We believe in that as well, and we'll get to that on the next slide. But it also needs to provide a high degree of privacy and protection for the UAV operator. We believe in PII as well, that people that are out there conforming and doing the things that they want to do are law-abiding, that should be left alone, and we can leave it to the authorities to determine how to manage with them and identify who they are beyond any other types of activities. This also optimizes speed to market because these are infrastructure components that we already have today. The capabilities are already on the drones. The infrastructure is already here. It helps expedite our path to market. It enables near real-time ID emergency for emergency situations. So if there's an officer or public safety people on the scene, that they can use a device to be able to ID that device and then turn around and find out who the operator or owner is of that device and act accordingly. It'll need to provide a glide path to UTM, and I think the beauty of this is the backward compatibility. As long as these devices can broadcast, we all carry phones. As we were talking about, we can see the device flying around on this phone, but there may be some that don't sign up for UTM. And so it really allows both of these areas to work in conjunction with each other. So you can track visually or you can track via UTM, depending on how they broadcast or network. So how does it work? We have a very simple approach. Somebody purchases a drone. The drone is registered at some online or authoritative registry. Serial number, other owner data, and very much in line with what AirMap was speaking to. They assign an SSL. That SSL can be with that for the lifetime of that device. It's then updated with that information. So now there's a correlation so that if this device is being used somewhere, they can identify it and identify the owner. Once it's been downloaded, it enables this drone to do the kind of flight that it's been programmed and developed and manufactured to do. And as our gentleman from DJI stated, most of these capabilities are on the drones already today. So a very glide path into this system. And it gives a unique data set that allows law enforcement and other stakeholders information need to positively ID the UAS and the owner. Why does this option work? It's the most economic and reliable drone registration and positive ID. It mimics what we've done in telecom. It mimics what we've done in internet. All of these are supported by the infrastructure, the people that are using this versus taxes and other ways to generate the funds to support this infrastructure. It minimizes the hardware that needs to be added to the drone. It leverages the existing infrastructure. Digital certificates, ADS-B, Wi-Fi, all these technologies are here today. It allows for the industry-wide adoption and standardization while minimizing the impact on the OEM. As we said, most of these devices already have these capabilities today. It's just how do we put those capabilities to use. It scales to accommodate demand and coverage for millions of drones and provides consumers with an additional protection in the event of lost or stolen IV. Positive ID should be required for all UAVs and is a foundational element of a pathway to UTM. Thank you.
Thank you very much, Mr. Stewart, to present us your positive ID, referring the telephone communication system technologies. You highlight that reliability, scalability, and global harmonized standard is necessary in this area. Thank you very much. So I'd like to present fourth speakers, Mr. George Elmasry, Principal Engineer, Rockwell Colleen, is a graduate of New Jersey Institute of Technology with a PhD in electrical and computer engineering. Currently a principal engineer with Rockwell Collins Advanced Technology Center. George has over 60 publications and patents, and he authored a book on tactical wireless communications. He also contributed to the McGraw-Hill Access Science Encyclopedia. Among his awards is the prestigious Hashimoto Prize. The floor is yours.
Thank you, everyone. I hope I'm bringing a different point of view than what we have heard so far. Most presenters you've heard so far are from drone manufacturers or small business, they startups, and they're coming up with creative ideas. I hope to get you a different perspective. Rockwell Collins is established large corporation for avionics. Rockwell Collins is multinational, and we're a large company. We're used to regulations before we develop. So I hope to get you now a different perspective, and I want to give you some history. The airlines established a consortium long ago. They called it Air Inc. Direct, and in the early 2000s, they sold it to Wall Street as a company called Air Inc. And Air Inc. was acquired by Rockwell Collins about 4 years ago. And Air Inc. have something called Air Inc. Direct, in which they serve small operations of aircrafts, private aircrafts, politicians who are flying, corporations, either in the US or multinational corporations who have private jets. And Air Inc. Direct influenced it a lot, so much we're approaching the drone services. We have been established as probably the dominant service provider for the small private jets, and we have seen things that work, and I want to show it to you in this presentation today. So some of the things we inherited from that. Of course, drone operations are totally different from manned aircraft. That's we know. But there are some stuff we did for manned aircraft services that we think it will work well for drone services. We're approaching these drone new field, wanted to be a service provider for drone operators. So I'm going to bring you this perspective today. Some of the things we found it works well for these small private jets is what we call it microservices. So we can deal with a multinational corporation who own a fleet of 10, 12 private jets, and we give them what we call it microservers. We give them a gateway or a server, and we give them a service package that suits them, and we serve them the way they like it. And that seemed to work very well. We inherited that for the large drone operators, like the railroad companies who want to inspect railroads with drones, power line companies. We brought that microservice concept to them, and they liked it so much. Another things we learned from private aircraft services is what we call it separation of computational engine from services infrastructure. We found that there is a lot of people out there who can develop good computational engine, better than the one we develop in-house. So we did this separation. Anything that needs calculation, we call it a computational engine. We separate it from the services infrastructure so that we can come to the end customer who we're serving and offer them service packages, and they can choose which computational engine to use. So you can find people who buy better computational engine for weather because they care about that. So what we're used to is bundled services. So I hope to bring you these concepts, and that will be a different angle from looking at US services. So the product we talk about, we call it WebEOS, and it's a highly secure architecture. We're very much into the security as a first step. I can go on to explain a lot of security with this product, but we have published a public domain paper in ICNS 2017 that explains the security in details. It's, as I said, a network of microservices and gateway. We can have a gateway dedicated for a large drone operator, and we do that now. And we can also, if we have multiple people who are not large drone operator but are in the same industry, so they might need the same service package, we can create a microservices for multiple of them. Like if somebody doing crop dusting and there are small operator who do crop dusting, they will need the same sort of services. We create a microservice for them. It is a cloud computing approach, and we care about building the infrastructure before we do the standardization. And we look at it growing in the US and internationally as well. So what we address with that, the first thing we address is we are a private company. We want to make money. So we address that UTM services. We want to be able to offer services for US operators. That's our first goal. Our second goal, we have to adhere to the regulation. We come from that point of view. We do not develop before regulatory comes, or if we develop, it's a prototype. It's not a product. We wait for regulations. And we want to adhere to explicit interface needs. So right now we work with the FAA, so we do interfaces with the FAA systems. Also, the FAA is promoting that we interface with peer US service providers. If you're involved with the land-sea effort with the FAA, there's a talk about these multiple service providers interfacing to each other aside from the interface to the FAA systems. We look at how we interface the air traffic controllers and work in that a lot. We think there are different interfaces. One to FAA systems like SWIM. That's separate from interfacing to an air traffic controller in controlled airspace. We really need to think about that as a separate area. And other network is an organization. So we look at this compartmentalization that we can have build a part of the cloud in the US and another part of the cloud in the US addressing different industries, but also international systems. So I'll go quick. I have the last slide have a figure that will cover everything in details. So we have these dedicated microservices for US operators. It's security. Security is important for us. As I said, we separate the computational engine from the infrastructure. We care a lot about the interfaces. And we have what we call it the CSOC. The CSOC currently, for offering manned aircraft services, is a secure operational facility. And we inherit the same concept in a cloud hierarchy for UTM services. We will have a CSOC-like, and you'll see that in the last slide with the figure. And we build the microservices as hierarchical lower down. We can create multiple level of hierarchy out of that. And we also care about the interfaces, as I explained before. So what we were here to address international, global UTM systems. So how do we see it? And we're not putting sticks in the ground. We're not saying this is how a UAV will register. But we think that we have a need to define new interfaces when we go internationally. Because we see that a foreign nation system can be different from how the US does it. And we don't want to tell a foreign nation what to do. In other words, we want foreign nations to develop their systems, and we actually have branches of our companies in Europe who are working in UTM, but working on it as a microservice. They're not tied to the way we work on it in the US. And that is giving us this idea that a foreign nation system can be another compartment of WebUS, but it's a compartment that adheres to this foreign nation standardization. So we're not telling someone what to do when we shouldn't. So there'll be fundamental components like the registration, and we heard about it a lot. We think it might differ from one country to another, and we'll see that. We'll see some country will say, I'm going to use cellular services for US to register, but we might see some other country says that's not secure. Somebody can hack the US and crash it. So we might find some countries use secure communication systems only. So we're not going to dictate how it will happen, but I would say it may differ from one nation to another. So we want this microservice in foreign nations to adhere to the foreign nations' standardization. We're not touching that. As you do that, the UTM services from one country to another might differ. You might find some countries going aggressive for full autonomy, and some other country is slowing down full autonomy. If you go to the FAA services, they think full autonomy is going to be decades from now. So, but some other countries might promote full autonomy faster. So this is going to be a compartment alone, adhere to the host nations. So UTM services might differ from one country to another, but we must be able to create this harmonization. And we have an idea of that, how to create universal, we need to create universal communication terminology. In other words, it's just like when you go to a foreign country, they speak their own language. Then you come to Canada and the US and we speak English. So somebody have to translate between these two languages. We cannot just go to foreign countries and say, you must speak English. So we will need some translation of records. And as long as the US is flying locally, why do I care? But once the US crosses the airspace from one country to another, this handover have to happen. Just like when I landed from the US here in the airport, my phone told me, you are in a foreign country, would you like to buy services here? And these phone service providers have worked that out, that they handed me over to a foreign country to buy their services. So the control and tracking will require handover, and handover will have to happen according to standardization. So we're looking forward for this ICAO to look into how we can translate records from one country to another, how to do handover, and not stepping in anybody's domain saying, I will force you to do things in a certain way. And keep in mind, our experience, we're coming from manned aircraft services, but we're very much aware that UTM will be different from manned aircraft services. This is the most important slide in my presentation. So what you see in the middle is this interfacing capability. This is how we architected WebUS. In the right-hand side, the second part, the second block, is called the CSOC. This is already existing. We have a CSOC. We have a root server for WebUS. We have computational engine that's already developed that we can communicate to. And we have developed microservices for railroad operation and microservices for power line inspection. And in these microservices, we integrate US services into the large drone operator. So that also all exists. And we're working with the FAA and Land Sea to look how we interface to peer service providers of US services, which is on the right-hand side here. And the left-hand side is how we see it grow internationally. It is its own compartments internationally in different countries. And it become, in a foreign country, another compartment of WebUS. Through that interface in the middle, this is where we need to work the standardization. That if a WebUS record in Canada is different from a WebUS record in the US, and a US will cross the airspace from Canada to the US, then we have to work through a handover and translation of record from how Canada decided a WebUS record will look like to how the US decided how a WebUS record would look like. Also, in that architecture, we have actually people in Europe who looked at this architecture and found that through this interface, they might be able to use a computational engine that exists is in the right site. So if we have a computational engine in our CSOC that somebody is developing a compartment in Europe, says, I need to use this computational engine, our interface that we build allows us to make him pass us, say, a data structure with details. We do the computational for them and passes them information back. So this compartmentalization does not negate the use of certain computational engine if it applies between one country to another. For example, we have a computational engine that you can give it fenced areas and tell you if your flight path is a yes or a no. So that one can be a universal, can exist in the CSOC, and the international systems will use it. But if the foreign country decides that you're going to do the computation in a different way, then the computational engine will reside in this compartment. I'm done with my time? Okay. That's the end. Thank you.
Thank you very much. You proposed a secure web UAS service based on your experience of manned aircraft service, and about the interoperability, global interoperability, you highlighted the importance of universal communication terminology setting for necessary information exchange. That's really interesting. Thank you very much. So let's move on to the Q&A sessions. So I have an iPad that a lot of questions. Okay, so I like to propose the questions randomly. So this. So this is a question for. So sorry. Sorry, I forgot to your name. Sorry. So, Mr. Stockwell, I'm sorry, I'm really sorry. So this is a question for you. So with a DJI system, you can set it on a waypoint mission. You can turn off the fail-safe feature and then turn off the C2 link. How will we then be able to track drone with the C2 link off?
So, so the question is really, if you have something running autonomously, is it still transmitting on the C2 link? And that's something that we can configure in our software. So it may not be actively needing someone controlling it, but it can still be broadcasting status. And so this is basically the ID and tracking is just part of a status broadcast. So if ID and tracking was required, we would make that a mandatory function to be transmitted, would be our answer to that.
Thank you. So the next question is to Mr. Ablon. So about the cyber, a number of events have compromised the TLS-SSL system because of the certificate distribution scheme. This would compromise large numbers of flying machines. So what is the view of how to deal with compromised ID system and implication of safety?
So the nice thing about TLS SSL certificates is that you can revoke them if there is some kind of compromise. So there have been some incidents in the past, as there are with any system, that there have been some certificate authorities who were not trusted that were still issuing certificates. And so I believe that's the compromise that this person is talking about. And those have been found out, the certificates have been revoked and not trusted any longer. And so there's a system in place to deal with these incidents when they occur. I mean, today, your online banking, your online email, everything relies on these certificates. So it's not a fundamentally broken system. It actually works very well. And when these incidents do happen, there is a way to remediate and mitigate against them.
Thank you. And this is questions for all of you. Considering safety or secure and million or billion quantity of drones are there, what broadcast method should be more suitable at present and the future too?
Sure, I guess I'll take that. So I think this is, actually I'll follow up with kind of some commentary that the moderator mentioned yesterday about regulatory, and that is not to exclude any bands that are available for broadcasts and to keep all of them open and available so that people can scale the business. So whether it's Wi-Fi, whether it's ADSB, LT, all of those should be and remain available for this service.
So, I'll echo that a bit, and I think you have to remember there's a huge variety of drones flying. So there's things we rightly called, drones, which are smaller and lighter than a water bottle, and the solution that's appropriate for this may not be appropriate for something that's much larger and more capable, and may have other equipage like ADSB and other things similar to a manned aircraft. And so it's probably hard to say there's going to be one solution, and there's maybe not a good reason to even say there should be one solution. So we would argue as well that let's keep all our options open and look forward to different ways to take advantage of what the capabilities of each type of drone and what's appropriate for that size and weight and capability.
So that means, so maybe it depends on locally and it depends on the environment. So it's better to keep the options, and maybe local government or the country may decide the best way to the situation.
If I may add on, I think it's very important to have service providers sharing information with each other. That is a very key point for safety and security. And we see that in a lot of industry. There will be resistance of sharing information because it's the client information. It's how I'm making a living. And regulators have to come and encourage how service providers share information, because one service provider might be working for small drone sizes, and another service provider might be working for the bigger ones, and the communication systems on the two are not compatible. And when it comes to really want security more, regulators should encourage industry and service providers in sharing information, even if it is filtered without the parts that can mean stealing business, basically. So, if the more we share information, the more we're going to get insight into the airspace view. And the more we need to add to the capabilities of the UAVs, on the ground, prediction of potential problems that can happen, and warnings that can be generated on the ground, not between the UAVs itself.
Do you think?
Yeah, I mean, I would just echo the points that I think all broadcast methods should be available, and I believe that that having, if you have the access to the information, the receiver, if it's open to all of those methods, then it doesn't matter how it's broadcast, and in different situations, different broadcasts make sense.
But At the same time, when we think about the efficient UTM system, and if we want to allow more maximum aircraft inside of the same airspace, sometimes you may need more information than traditionally, like the performance of the clearance, or so maybe the information can be varied, and a lot of information may transfer. And so in that case, maybe which information should be shared or which information should be secured to the personnel could be another topics to discuss, I think. What do you think about like who can decide that?
Sure. I mean, if we peer in UTM world, we should absolutely exchange and interop the data, but you certainly want to keep the competitive data and your market data to yourself. So the route, maybe some aircraft data that you want to exchange, and where it may intersect with what your partner or peer UTM may have that data. That's the ideal data you'd want to share. But beyond that, you would probably put some parameters around the privacy of the information, but also the protocol that you would deploy to speak and peer between the UTM to UTM would be some level of NIST cyber secure type of security as well.
I have seen some simulation work being so much into research that says if you rely on full autonomy, and as the aerospace becomes more and more dense, the probability of some problem happening increases. And it makes sense, right? But you can see curves in that and research work that if I'm relying on full autonomy and I'm putting more and more UAVs in the same space, some UAVs might not be too sophisticated to react quickly. So one of the things that I think we should look at is, although even if we rely on full autonomy, that the service provider can provide a parameter for how dense the airspace the UAV is flying in it. And that might even change the speed of the UAV. It might slow down in order to, in full autonomy, to prevent problems from happening. And I'm saying that even if we think we can reach full autonomy quicker than what we will reach it will take decades till we reach it. But even if we get to this point, sharing information between service provider can actually be helpful to full autonomy. Full autonomy still can use that information to slow down, change trajectories a little, all that can happen. So sharing information is critical, and that's where regulators need to come and encourage industry on sharing information.
So I think this is a very interesting and deep topic that just points out so many different issues with how we're going to deal with UTM, whether it starts with privacy of the operations and the importance to commercial operators and recreational operators, that there's some notion that what they're doing is valuable to them and it shouldn't necessarily be broadcast to everyone. And that has to be balanced with the clear sort of safety and security and coordination that will need to happen when there's a lot of automated drones flying around. And I don't think any of us, I think it's an ongoing process. If you talk to any UTM provider, this is something they're trying to figure out on the back end, what needs to be traded and how to trade that privately and securely. But I'm going to make a pitch for my talk in the next room, in the next session, which is that when you think about traffic management, it's more than just traffic control. And so I think, as you were saying, there's other information that can be traded between vehicles and between automated vehicles. So there's sort of a space between the traffic control service where you're trading information on the back end and what an automated drone might be seeing in front of them and how they're dealing with the situation in front of them. And so there's another layer of data exchange and standards I think we need to talk about, which is how does one drone talk to another to coordinate in real time as they approach each other, and not be forced to rely on some back-end service that may or may not be available in real time for them right there. So I think these are great topics. that I don't think anyone has a great answer right now. I think it's an ongoing point of research.
Yeah, I mean, I'll just add that, you know, we're involved in different efforts with data sharing. NASA UTM is working on data sharing. You know, we believe it's definitely critical for the industry, and working out what are the right things to be able to share, right, to protect the privacy information. A lot can be done in terms of taking, if you share too much, then obviously you can de-anonymize certain things. So making sure we have the right balance of sharing for safety, as well as making sure we're keeping privacy information safe.
Thank you. So move on to the other questions. Is it possible or necessary for every drone to be tracked at any time, or is it only necessary for some certain situation to be reacted at the most timely manner?
So I'll just say, you know, I don't think every drone, I mean, if you're flying indoors or if you have toy drones, you know, I mean, not everything needs to be tracked, right? But I think in certain situations, and this is where regulators are going to come up with what makes sense in terms of, you know, what are sensitive operations, where do they want to see the ID? Is it only in controlled airspace? Is it over people? Is it over critical infrastructure? So, you know, I think those decisions, you know, will come to the regulator, but, you know, I don't think every situation warrants, you know, remote ID tracking.
I would echo those comments. I think when you look at toys, there's no reason to assign an ID to that. And tracking can actually be either networked or visual. So there are different ways that people can consider tracking. So tracking can be dependent on what purpose that the UAV is flying in, and whether they're signed up with the UTM or if they're just a hobbyist out in their backyard flying around.
So in a discussion of your countries about the UTM, like, so is it like even in airspace that UTM want to control and want to reserve the airspace, but you still think that there is a recreational aircraft may fly, so that the operator who reserved the airspace should think about some drones, or is there any airspace that you can reserve so that no other aircraft, drone who don't be tracked cannot enter? How it is like?
For me?
Yeah, like who can
I see this point have to do a lot. You know, regulation didn't come yet, but I think when regulations come, I think that will differ from where you're flying. If the airspace is dense in a city, I think we will require more registration, that everybody has to register. But if we go to rural areas, somebody is flying in a national park taking pictures, I think regulations will be a little more loosened for registration. But if you see how the FAA looks at it, right, till now the FAA is putting the burden on the operator by saying you have to have visual line of sight. So the FAA is saying it's the responsibility of the operator right now. But as we move into the future, I think if you, and I've seen that in where I live in a large city, I've seen people flying drones next to airports. And although they're hobbyists, they shouldn't do it. That restriction for them, they should be forced not to do it close to an airport, because they're flying not only in controlled airspace, but they're flying recklessly. The regulation should stop that. But if you go in rural areas, they might be able to fly. They're not bothering anyone. So we have not seen how the regulation came yet. But I think it will differ from one country to another. It will differ from one city to another. You know, municipalities might require things now as the airspace gets very dense over them.
So we have a pretty strong opinion on this, and right now, most of my experience is in the United States, and we have at least 10 times as many recreational flyers as we do commercial flyers. And so when you're doing recreational flying, you're supposed to be doing visual line of sight, and in a park this size, you could easily see 4 people flying around safely because they're controlling their aircraft, they're seeing what's around them. And if somehow there was a requirement that, you know, someone who's part of a UTM has somehow reserved this space so they can fly through at 10:05 a.m., like that's just not going to be workable because, you know, unless you are forcing recreational flyers to be part of this UTM system in a way that, you know, it's just, I think you come to an issue of you know, are people actually going to do that? Like if I go to the park and I have to stop flying every 5 minutes because someone else has reserved for a commercial purpose, that's just not workable, I think. And so we would kind of flip that around and say, look, if you're a delivery drone, for example, you're flying beyond visual line of sight, you have a very different kind of risk profile you're doing, and that's risk you're imposing on the airspace. You're going to have to deal with birds. You're going to have to deal with other things that are flying. You should have to deal with recreational drones as well. And so I think from our point of view, we would kind of push some of that to the UTM people. Like, this is a question. How are you going to deal with it? Rather than saying, there's a reservation system and no one else can fly in that reservation system. I think there's always going to be this kind of background traffic of recreational flyers. And ultimately, I think that's a good thing. I mean, the recreational drones are really what's driven a lot of commercial applications today and bring a lot of people into aviation. And I don't think we should discourage that or make that so burdensome that no one will want to do that.
Okay.
So I think there will be a definite mix. You know, you'll have certain areas that will be congested where you'll have to dictate where people can and cannot fly. But we actually see some of this in manned aircraft today. We have operations out in like West Texas where ranchers will take off from their ranch to herd their cattle, and they're not chirping or beeping or talking to anybody. So we deal with this already today. That does create challenges, but there'll be certain areas that they will have no-fly areas, and there'll be areas that maybe they can submit a waiver for like an AMA type of location where they're going to have events, so they don't have to worry about putting their aircraft up or down because other aircraft are coming into the area. But I think it'll be a mix. It'll be dependent upon the capabilities in the region, you know, the geography of the area and so forth, population.
Thank you. And it is about ID. What makes the identity of an aircraft? Like if it is bought by manufacturer, it is like there is a serial number. But what happens if you change the flight control or if you change some structure of the aircraft? How do you think about the identity of the aircraft that you are going to register in your system? What do you think?
Again, I think that will be different from one nation to another. You know, regulators in different nations will decide how a UV record will look like. And for all practical reason, as long as the UV is flying in the country alone, then there is no issue. That record is tracked based on the country. But for this body, for ICAO, what we need to think of is what if the UV hands over between airspace? And that is when you need to translate the record from one country's format to another. We've seen, say, in cars industry, there is a VIN number that follows international regulations. And if ICAO decided that they will create something similar, that the ID of the UV will be international ID, we still have a chance that the record itself of the UV in one nation might differ. Like one nation uses meters, the other uses feet, and when you hand over, you have to translate meter to feet and feet to meters. We will face these areas where if a flight will be in, you know, crossing airspace from one country to another, we need ICAO to come in and help us create a standardization, how to translate the records from one nation to another. And that's what I think of it. It is not a global database, but it's universal. So every country have their own database, but there is a translation method between the countries.
So again, this is a great question, and I think it gets at some of the deep issues of the difference between identifying the drone and the idea of registration. And so, for example, in some countries, you can get a license plate that you can switch to the car you're actually driving that day. And so I think the question that you really need to ask is what am I trying to do with this ID? If I'm trying to get the person, then I probably need a registration number that follows the machine. If I care exactly what that machine is and who owns that, maybe the manufacturing serial number. And CTA has actually released, the Consumer Technology Association has released a standard for drone serial numbers that some of us have worked on. So that might be a path forward. But I think any solution based around the machine is going to be sort of a 90% solution, because there's always going to be a situation where a hobbyist builds something, or you buy your drone and crash it, and over the course of the year, you've basically replaced every piece of it. So what is the serial number of this thing once you've rebuilt it 20 times? And I think that just reflects the huge spectrum of drones and UAVs that we're going to have to deal with. And again, things smaller than this that are still pretty capable and have cameras and can fly pretty far, all the way up to really something that could be piloted by a person but is now unmanned and is crossing international borders. So it's going to be a hard problem for regulators, and I think it's going to be, I think, in my opinion, we should resist the idea that there's one easy solution. And I think we have to think of a spectrum of solutions that are overlapping in some ways to just cover the huge spectrum of UAVs that are going to be flying.
Yeah, I mean, I think I would say, registration and ID, if you separate them out, they are different, right? And maybe a registration system, you would like to know what kind of aircraft, and if things are modified, you'd want to track it there. But the ID can be separate from that, and it doesn't necessarily have to be tied to the serial number, although it can be. But an aircraft that has an ID, even if you modify it, it can still have that ID. If you take your car that has a license plate, you can change the engine, you can do a lot of different things, but it will still have that same license plate. So
thank you very much. Very interesting discussions. Thank you very much for the speakers. And thank you very much, audience, to stay in this room by the end of the presentation. Thank you very much. Thank you.
Thank you very much, Dr. Nakamura, for guiding us in this very exciting session when you start discussing the nuts and bolts about how to build a reliable registration, identification, and tracking system. That was very interesting. As I'm coming from a place in the world where the soccer games and the soccer is the major thing. No game is really great until you get also the second half. So we'll have another second half after a well-deserved coffee break. So I will invite you to join us outside. The coffee break today is sponsored by Skyward, a Verizon company. So thank you. I will see you here exactly at 11 for the second half. Thank you.